I was trying to make it a harder problem than it was. I think the degree of difficulty of the previous 3 or 4 problems caused me to overthink this 38.
Oh, okay.
Because I think it's as straightforward as that. In fact, when you get to trig, the first thing they teach you is how to calculate that arc length, and it's that angle in radians times the radius is what that arc length is. And that angle in radian is 1/10 of 2 pi, or 2 pi over 10.
Yeah.
So, all right, let's go to 39.
Okay. So if I squared equals -1, what's the value of 4 plus 2i? 4 minus 2i. So that would be 16 minus 4i squared.
Good. I'm glad you could do that. I'm glad you could do that quickly. In other words, you apparently recognize it as the difference of squares factored. So putting it back together again doesn't require you to FOIL it. It just requires you to know what the difference of squares would look like.
Yep, exactly.
Okay.
So then if I squared equals -2, so it'd be 16 minus 4 times -1. So that would be 16 plus 4.
Okay. 20.
So that's 20. This would be, okay.
Now let's see. Hold on. How many of these curves do they give us here to look at?
1, 2, 3, 4, 5.
Yeah. Let me minimize it a little bit. See if I can get all 5 of them on there. Yeah. Okay.
So which of the following could be graphed?
Could be the graph of that quadratic.
Okay. So that's a quadratic function.
Okay.
I'm trying to remember the formula. It's like ax squared plus bx, I think, plus c.
And that's exactly the format that they give it to us in.
Okay.
So A would be 175, B would be minus 33, and C would be minus 2,000. But there are, before we go that route, we know a few things about this quadratic. Does it turn up or down?
It's going to be, it would look like f, g, or k. It would have that concave up thing.
It would have to turn up. In other words, what causes a parabola to either point down or up is whether that sign, that coefficient of the leading term is positive or negative. So the fact that it's positive, you're right. It has to be f, g, or k.
Yeah.
Now, let's see. What's the y-intercept have to be?
Well, I'm trying to remember. I forgot if it's B or C. I know it'd be below the.
In other words, remember this: the y-intercept always happens when x is 0.
Okay.
So that makes it C. Because when you plug in 0 for x, it eliminates the first 2 terms of that quadratic.
Okay.
So minus 2,000 has to be the y-intercept. Well, that could be f or g, but it can't be k. K is above the x-axis.
Yeah.
So now we're down to f or g. What is the key distinguishing factor between f and g?
The, what's it called? The shift.
It would be the x-coordinate or the line of symmetry. Is the line of symmetry a negative number or a positive number? F, it's negative. G, it's positive. Well, how do you get the line of symmetry? It's the same as the x-coordinate of the vertex.
Okay.
Did you remember what it is?
Say that, it was loud. Like I couldn't hear you at all.
The x-coordinate of the vertex. Oh, you mean when I was moving the stuff around? That makes a lot of noise. Huh.
Yeah.
Huh. I didn't know that. Thank you. What is it?
I'm trying to remember.
What's the first
sure.
half of the quadratic formula?
So, okay.
It's minus b
Plus or minus.
over, no, by the first half I mean...
Oh, so negative b, oh, negative b over 2a, yeah.
Yeah. One of the ways I try to teach people to memorize the quadratic is the fact that minus b over 2a is also the way you get the vertex of a quadratic. So the question is this the only thing we need to know to answer this question is whether that's a positive or a negative number. If it is a negative number, then it's f. If it is a positive number, then it's g. Do you see that why that would be the case?
Yeah, that makes sense.
Okay, so what is it in this case?
So negative b, so 33 over 2 times 175. So
Positive
33
or negative?
Positive.
And that's all you need to know. You don't need to know what that value is.
Okay.
You just need to know whether it's positive or negative. So we really didn't have to do a lot of math in this. There's a few other ways that you could do this. Given you're going to have a you don't get a graphing calculator though, do you?
I don't think so.
No. In other words, we certainly are going to have a tough time finding the x-intercepts. That doesn't look like it's going to be particularly fun to factor.
Okay.
So trying to figure out what the x-intercepts are is a fruitless task. I really think the easiest thing here is to try to spot the vertex, which side of the y-axis that it's on. And that's easiest done using minus b over 2a. So maybe that's just one of those things you need to memorize for this test.
Yeah.
I didn't think so. In other words, I haven't really come across problems for the ACT before where you needed to know that. That's why I was looking for another way to figure this out.
I don't know if it would work at all, but I was thinking if A and B, like A and B were different, like if it was negative and positive, since they're different, wouldn't that mean it would shift to the right automatically?
You put your finger on it. In other words, since the vertex is minus b over 2a, then if the signs on A and B are the same, then it has to be to the left. If they're opposite, it has to be to the right.
Yeah.
That's good to know, I guess. Yeah.
Yeah.
That's all you really need to know. You don't need to know b over 2a. You just need to know these signs. If they're opposite, then that vertex is to the right of the y-axis and the other way around.
Yeah.
Let me blow this back up a little bit so it's a little more visible.
So 41. So Sebastian bought a meal at a restaurant and left a 15% tip. With the tip he paid $35. How much did the meal cost without a tip? So I was just thinking you could just do, so you paid a...
Do you have a calculator?
Yeah, let me get it. Okay.
Grab it.
So since they paid 15% more, I would think it would be 115%. So then I would just do 1.15x equals 35.19, I think. Yeah, 19. So then you do 35.19 divided by 1.15.
Okay.
Or x equals 35.19 divided. So that's, let me get it. 35 point divided by 1.15. I got 30.6.
Yeah, that's definitely a good way to do the problem. There's absolutely nothing wrong with doing the problem like that. Back solve it for me.
So you want me to look at the...
Yeah.
Oh,
In other
that would
words,
make sense.
if you were not able to formulate what you just did, the way you could solve this quite easily would be to back solve it.
Okay.
So do it just to practice back solving.
So would
Don't
you
start with the correct answer. Start with B. Just get a little practice.
So with B, that is
Assume that's the correct answer.
29.
Yeah, try to either prove it or disprove it. So what would you do?
Can you do the...
Go ahead.
Oh, wait.
Multiply that by your
I was trying to think.
5.
Yeah, that's that. I was thinking. So you do the... Don't you just do the 29.91? And I'm thinking, would you do the same thing and divide it?
No, you'd multiply. In other words,
no, you would multiply it. Yeah.
Is your bill, you would multiply it
Yeah, you multiply it.
by 1.15.
Yeah.
What does that give you?
33.35.
So you know what?
So that B doesn't work, so A wouldn't work either.
Well, you know you need a bigger number.
Yeah, bigger, yeah.
That's what you know. Now the next thing to try would be which one?
D.
D, because that will tell you the answer 100% of the time. Either it will be the correct answer, or you'll know you need a bigger number still, so you'll know it's E, or you need a smaller number, so you would know it's C.
Oh, okay, that would work too,
So
yeah.
the beauty of back solving on a problem like this is you know which direction you have to go if you don't come up with the correct answer on the first try. You always know you need either a bigger or a smaller one. And whenever that is the case, you are at most going to have to try 2 answers, which isn't a lot of work. In other words, multiplying this number by 1.15, realizing you're incorrect, and then you have to multiply this number by 1.15. Whether that's more or less work than your formulation was actually slightly less work. But it's not always that easy to formulate the algebra. This problem was, but a lot of them it isn't. In which case the back solving is a much superior method.
Okay.
And I love to back solve on problems like that, only because they lend themselves to back solving so well because of that aspect. Even if the algebra is easy, I like the back solving.
Yeah, I should do that a lot more.
Well, I just want you to consider it with some of those. Your algebra is certainly good enough that you can formulate most of those.
Okay.
So if the sine is equal to that, what's the cosine equal to?
Let's see. So sine's opposite of, or no. So if it's 7/8, when you just have to do, so opposite over adjacent equals 7/8, can you just do, can you use the Pythagorean theorem? I was thinking. So it would be...
So you always want to answer these problems by doing what?
Using the Pythagorean.
Drawing a triangle, a right triangle.
Yeah.
That's always step 1.
Okay.
Whether you're taking trig class or you're taking the ACT. You want to draw a right triangle and label A, because it's the sine of an angle. So little a is an angle. Once you get this part done, now you can label 2 sides of that triangle. Which 2?
A and C.
Which sides?
Oh, you can do the hypotenuse.
Which is what?
64, 8 squared. 64.
No. In other words, when they say the sine of angle A is 7/8, that means that side is 7 and that side's 8.
Oh, okay. Yeah, you can do that.
Because
I
it's
just
the
kind of did the
opposite.
Pythagorean theorem in my head already.
It's the opposite over the hypotenuse. So it
Yep.
always allows you to label two sides of the triangle. And the only thing we're interested in is ratios. In other words, maybe this is 14 and this is 16, but it doesn't matter. It's the same ratio.
Okay.
Because they're asking about another ratio, the cosine of that angle. So what is this third side?
Let's see. So 49 plus b squared equals 64.
If you look over at the answers, you even know what it is before you have to do the calculation.
Oh, let me look over.
What must it be? Just for that third side.
Oh, let me look. I was thinking of the square root of 15.
Well, it has to be, doesn't it? I mean, square root of 15 is in 4 different answers. If this isn't the square root of 15, I'll be a monkey's uncle. And it's the square root. It should be the square root of 64 minus 49. So it is the square root of 15. But my point is that rather than having to do that calculation, if you look over there, you know what is going to, it's instant. That you know it must be root 15. So now, what's cosine of A?
So that's adjacent over hypotenuse. I think. Wait. Correct. Yeah. So square root of 15.
So ka toa.
Yeah. So that's
and
square root
I
of
emphasize the ka like a crow calling. So ka. Because so katoa, the middle could be anything. You know what I'm saying? In other words, there's so, but if you said ko, it could be like that. So to make it ka, you have to say so ka toa.
Okay.
You really want to get to a point where you don't have to refer to SOHCAHTOA when you think about trig.
Yeah, I need to get to that point.
So what's the cosine of A?
The cosine of A would be square root of 15 over 8.
H, yeah.
Okay, so 43, I think we're on. So in the real numbers, which of the following is the domain of the function square root of x minus 3, x minus over x minus 3? So if it's real, okay. I was thinking
just what is the domain of that function? Forget all their other stuff.
Yeah, I was thinking of solving.
No.
So
remember, domain is the allowable values for x.
Oh.
That's all domain means.
So wouldn't it just be, I was thinking b, then? Greater than, would it work greater than 3?
I think B is the correct answer. In other words, it cannot be 3, because that makes the denominator 0.
Yeah.
And it has to be greater than 3 for the numerator not to be violated.
Okay.
So greater than 3 is the answer.
Yeah, I was going to just solve it. I was going to just do x minus 3 is greater than or equal to 0, and then x is greater than or equal
I see what you're saying. Yeah.
Yeah.
In other words, if you have two things you have to solve, actually. This thing cannot be equal to 0, and this thing has to be greater than or equal to 0.
Yeah.
Now, if you solve only that, you don't get the right answer because you get this.
Yeah. And then you just do x minus 3 equals 0.
Right. And since x cannot be equal to 0, it takes that part of it away.
Yeah. Okay.
This test seems to be more pre-calc and less algebra 2.
Yeah, maybe, I don't know. We are in trig, kind of, in a trig calc A, so maybe it's more based on that. Not too sure.
Yeah, I don't think the ACT has changed that much, but So I think we're probably just dealing with a particularly difficult test and the harder questions on that test.
Okay.
Is my guess. Because I don't remember questions about domain on the ACT test either, but I might be wrong there.
Okay. So, 44. So, Andrea and Zach are both waiting for an appointment. When they arrive, each receive a card telling the hour and minute of his or her arrival 2 minutes ago. Andrea has been waiting exactly 1/2 as many minutes as Zach. 3 minutes from now, Andrea will be waiting exactly 2/3 as long as Zach. But the time is now 11:30. What time did Andrea arrive? Ooh. I think I know what I can do.
What's your strategy going to be here?
Well, I was first going to make I was thinking of making just a little chart for the equations.
Okay.
So I was going to put A just for the number of minutes that they have been waiting. So, or the number of minutes that she's been waiting.
Okay, let's look at
2
this.
minutes ago.
Let's look at this a different way. When I was reading this, it reminded me of the questions that are age questions, where they say, Andrea, 3 years ago, Andrea was twice as old as Zach, and 4 years from now, Andrea is going to be 2/3 as old as Zach. Those kind of questions.
Okay.
Those are, to me, definitive back-solving questions.
Okay.
Now, I think we can do that here. Can we not? I might be wrong, but I do believe we can solve this with back solving. And whether it will be completely apparent whether we need a earlier or a later time, I'm not 100% sure. But it can't hurt to start.
Okay.
Back solving assumes an answer. I always start with B.
Okay.
Okay. So,
See.
if B is correct, Andrea has been here for 12 minutes.
Okay.
Hold on a second. I'm trying to wrap my head around this problem. 2 minutes ago, Andrea had been waiting exactly half as many minutes as Zach. So 2 minutes ago, Andrea would have been waiting 10 minutes.
Okay.
That's half as long as Zach would have been waiting. So Zach would have been waiting 20 minutes 2 minutes ago. Which means Zach would have gotten here 22 minutes ago, or 11:08, since it's now 11:30. So Andrea got here, Zach got here, and now does everything else make sense? 3 minutes from now, Andrea will have been waiting exactly 2/3 as long as Zach. Well, 3 minutes from now, Andrea would have been waiting 15 minutes. 3 minutes from now, it'll be 11:33, and Zach would have been waiting 25 minutes. Is that ratio 2 to 3?
No, I don't think.
No, it isn't. Now the question is do we know which direction we have to go with the time?
Won't you have to go higher? So,
Well, these are always a little tricky. Let's figure out what our ratio was. Our ratio here was 3 to 5. And it needs to be 2 to 3. 2/3 is a bigger ratio than 3 to 5.
yeah.
So let's keep that in mind. And now we know 1118 isn't correct, right?
Yeah, it's done.
So we're going to try 1133 or 1123.
Okay.
So that's when Andrea got here. So 2 minutes ago, she would have been waiting 5 minutes.
Okay.
Zach would have been waiting 10 minutes. Which means Zach has been here for 12 minutes. He got here at 11:18. 3 minutes from now at 11:33, he will have been waiting 15. She will have been waiting 10. That is the correct ratio. That is the correct answer.
Okay. So that would, okay. I kind of see what you were doing now.
Now, if this wasn't correct, we would now be certain as to which direction we need to go. Because the relationship between this ratio and 2/3 would be in the opposite direction as the other one. Or if it's in the same direction, we know we need to go higher still. So we would know the answer. So,
Okay.
I don't know. Can you think of any other way to solve this problem without back?
So without back solving?
Yeah.
Well, like I was having a little thought with a chart, a little bit. It would take a lot more time, but if I could show you how I think I would do it, but it would take a little longer.
Well, how about algebraically? Let's have it a
Yeah, I was thinking of making an equation. So I was thinking like.
Let's see if we can come up with a rather simple algebraic. But to solve any word problem, what's the first thing we need to do?
Set variables.
Okay, so if we let x be the amount of time that's passed, it's the amount of time Andrea has been waiting. Number of minutes that Andrea has been waiting.
Okay.
So 2 minutes ago, wow, so x minus 2 would be 2 minutes ago.
Okay.
Andrea has been waiting exactly half. We'll let y be Zach's wait time. And now a second equation would be 3 minutes from now. This will be 2/3 of y minus plus 3.
Okay.
So there you go. There's 2 equations and 2 unknowns. That will allow us to solve for x, which will give us our answer of 1123.
Yeah. Okay.
Super easy to solve these 2 equations and 2 unknowns, but it's not that hard. Alright. I'm not sure which is harder, back solving it or formulating this.
I think they're both be, I think they'd both take some time.
The back solving, that's one of the hardest back solving things to wrap my mind around that I've ever seen. But it was doable. It just, you had to be very, very careful not to make a mistake with the logic.
Yeah.
Whereas if you tackle it algebraically, you don't have to be quite as careful. In other words, this x minus 2 goes with that y minus 2, and then x plus 3 goes with the y plus 3.
Yeah,
so
that's
this
true.
is actually a rather simple formulation once you figure out what to call your variables. And that's not always as easy as, I mean, that's the difference between a hard word problem and an easy word problem. Is if your variables pop up instantly when you look at the last sentence, that's one thing. But you'll notice with this problem they didn't. You had to translate 11:30 with her arrival time to come up with x is the number of minutes she's been waiting. $45.
Okay. So in the following figure, each circle is tangent to the other two. Each circle is tangent to the other two circles, and the two shaded circles are identical to each other. What is the ratio of the shaded region to the non-shaded? I think I know what to do. I'm not too sure. Would you have to replace the radius with x?
It's a good starting spot. Which radius?
Since they're the same, when you of the shaded one, of the shaded circle.
Small. Yeah.
Yeah.
Let's call that R. We could call it X if you prefer, but there's no reason not to call it R.
Yeah. Okay. So we'll do.
So what is the area of the two circles, which is the shaded region? Let's call it that. What's the area of the shaded region?
Wouldn't it just be A equals pi r squared if we're just leaving r?
There's two of them, so 2 pi r squared, right?
Oh yeah, true. Okay.
Okay. What is the area of the big circle? What is its radius?
The big one. Wouldn't it still be the no? I was thinking it'd still be wouldn't it still be the same? 2. Wouldn't it just be pi?
What's the radius? If the radius of this, if this little radius here is r, what's the radius from here to here?
Oh, okay. I was thinking that the radius is like half of the large one. Or
It is.
Yeah. Okay.
Let me draw it different. What is the radius from here to here?
Yeah, half. So it'd be
2r, not half. 2r.
Yeah. Oh yeah. So pi 2r squared.
Right. So that's 4 pi r squared.
Yeah.
Because it's really, it's pi and r is 2r. So the area is 4 pi r squared. So their question is, what's the ratio of the shaded region to the non-shaded region? Well, first of all, what's the non-shaded region area?
Wouldn't it just be 4 pi? I got 4 pi r squared. No.
That's the area of the big circle.
Yeah, that's the area of the...
What is the area of all of this white there plus all of this white here?
Wouldn't it still be 2 pi?
Uh-huh. It's the big circle
squared
minus the area of the shaded region, right?
Yeah.
In other words, shaded region problems are always subtraction problems. We don't have the math to figure out the area of that particular shaped object there.
So
But we know that this white area has to be the area of the big circle minus both the areas of the two small circles. So the non-shaded region has to be 2 pi r squared.
Yeah, so 1 to 1.
Yeah. 1 to 1.
Okay. 46. Oh, this looks fun. Alright, so in the following figure, the line passes through the origin and through p equals 1 and 3. If you were to draw a new line perpendicular to the first that also passes through p, what would the equation of the new line be?
I want the equation of that line right there.
Oh, okay. So I'm thinking since it passes the origin, so it passes 0, 0.
Okay.
So you could just, so it passes 0, 0 and 1, 3, so the slope would be, let's see, up 3 over 1, so it'd be 3.
Okay. So the slope of what? The slope of this line is 3?
Yeah.
Okay.
So now, if you wanted to make it perpendicular, wouldn't you have to make it have like a negative reciprocal?
Correct.
So it'd be negative 1/3?
Yeah. And the way to memorize that is there's always two things you have to do. There's two words, negative reciprocal. It means you have to do two things. You have to make it negative and you have to reciprocate.
Okay.
It's amazing how many students I tell negative reciprocal and they repeatedly only do one thing. So the fact that there are two words to describe it, know that you have to do both of them.
Yeah.
So now we know the slope of this line, but what's its equation?
So if you wanted...
Another hard one. I mean, not that hard, but not what I'm used to seeing on ACT. I think these maybe are a little harder. Nah, I don't know, maybe.
Can you just plug in...
Yes.
I was thinking plugging in 3.
Plug it into point slope. What's the point slope format?
Point slope?
Uh-huh.
Isn't it...
slope intercept also.
Yeah, I was just thinking of y equals mx plus b.
All right, let's go with that. If y equals mx plus b, and we know m is minus 1/3,
Yeah.
still doesn't tell us our answer, because there's two answers on there that have minus 1/3. So how do we solve for b?
Let's see. I was thinking of, I don't know, I was thinking of plugging in
line,
3.
This line goes through that point.
Yeah.
Therefore, whatever the equation is, has to be true for this x, y value.
So you plug them in.
Exactly.
Okay.
So what should I do?
So 3 equals, I think, yeah, 3 equals negative 1/3 times 1 plus b.
Okay.
So then 3 equals negative 1/3 plus b. So b equals 10 over 3.
Which makes it k.
Yeah.
Yeah, and that's probably the easiest way to do the problem. The other way is if you remembered point slope format. That's exactly what we have here. We have a slope and we have a point. So it would be y minus 3 equals the slope of x minus 1. And then, of course, the problem with using point slope is then you still have a lot of work to do to get it into y equal mx plus b, which all of the answers are in y equal mx plus b.
Yeah.
So point slope is initially easier to plug in the point and the slope, but as long as you have to do all that work anyway, you might as well use y equal mx plus b from the start. Let's see, I think we have to go up for 47 now.
Ooh, okay.
another question about, I presume these are matrices.
Yeah, I think they look like it.
But I don't recall ever coming across really a true matricey question.
So you have to add them?
Yeah, this is not a hard one. This is actually pretty easy.
Oh, I get how they did it.
Yeah.
Okay.
Sure. So what's x?
So, I was thinking of doing it into making 3 equations.
It's not that hard. Don't make it harder than... We know what x is immediately. What's x?
Wait, to know... Oh, 9?
Uh-huh. No. 6 plus x is equal to 9.
Oh, yeah.
X is 3.
So 3, okay.
Okay. And now we know that x plus y is equal to 7, so what's y?
So x plus y, so 4.
And we know that y plus z is equal to 5, so what's z?
1.
X plus y plus z is 8.
Oh, okay. Okay, so
I think that's the easiest way to do it. You would have gotten there making your 3 equations, but that's overthinking it probably a little too much.
Yeah.
In other words, each of these little calculations you can almost do without knowing algebra. You know, if I went to a 3rd grade student and said 6 plus x equals 9, or 6 plus some number equals 9, what is that number? They'd be able to tell me.
Yeah.
And that's really the level of algebra that you need to do this problem, is all.
Okay.
Once you understand that that's a matrix and that this number right here represents that plus that, I mean, that's not necessarily that obvious, but so you have to know a little bit about matrices.
Okay. Okay, so 48. What is the area of the trapezoid? Oh, okay. Oh, okay. I see what they're doing. So I can't draw a trapezoid very well, but I'll try my best. So, that's pretty good. So they want you to drop down to the height, the thing.
It's that car. There's a car that looks like that. The cube.
What car? Oh, the cube, yeah.
Not the cube so much as there's one that's SC.
Like the soul.
Yeah, the South Korean car that looks very squarish.
Yeah.
So
I think if that's 60, I think you drop it down, yeah, right there. You drop it, and then that'll be a 30, and then that'll be a 90.
So what's the distance right here?
1.
Okay.
I think, yeah, 1. And then the height, and then
what's 3. The height?
Square root of 3.
Good. And that's 2, but we don't really need that.
No.
In fact, let's take it off there so we don't get confused.
Okay.
Now, you can do this 2 ways at this point. You can figure out the area of that triangle and the area of that rectangle. Add them together. Or, if you remember, the area of a trapezoid is the average base times the vertical height. Well, the average base is 3.5, between 3 and 4.
Mm-hmm.
And the vertical height is root 3. So the area of that trapezoid is that.
Okay.
Which is J. Notice that 3.5 is the same as 7 over 2.
Oh, okay. I have to.
Yeah.
Okay.
Now, if we were to do it the slower way, well, we get 3 root 3 for the area of the rectangle. And then the area of the triangle is 1/2 the base times the height, so it's root 3 over 2.
Mm-hmm.
Adding these two things together is a little more than just trivial. Don't you agree?
Yeah, that's a little harder.
Well, I don't know that this is the harder way to do it, necessarily, because the other way requires you to memorize the area of a trapezoid. Not everybody knows that. But let's look at this operation here. What we really have are 3x plus a half x, which is 3.5 x's. Only instead of x, it's root 3. So it's 3.5 root 3, or 7 over 2 root 3. So it's not that it's really terribly difficult to add these two irrational numbers together, but what throws a lot of people off is this division by 2 instead of putting that as a coefficient in front like that. In other words, if you write it this way, it becomes a little clearer that that's 3.5 root 3.
Yeah. Okay.
All right. But clearly, if you memorize the area of a trapezoid, that's the quicker way to do it, I think. Once you've solved for the height,
I think that's better.
Yeah, you use the 30-60 triangle to solve for the height, which I had to do also. So you can't start right out attacking this thing because you don't know the height. So you have to draw that vertical and figure out that height. And once you've done that, I don't know.
Okay, so we're on 49.
49.
So the following graph shows the number of new bank accounts that 8 account executives have opened so far this week. Which of the following answers is the median accounts among these people? So median is just the middle kind of thing.
Which means we have to do what?
Place them in like order.
We have to place them in order, which means we have to read each of them.
Yeah.
Or do we? How many we have here? We have 8.
Mm-hmm.
So the median is going to be halfway between the 4th shortest one and the next biggest one. So we don't really have to figure out. In other words, if we had to figure out mean, we would need these values. I'd need to know that's 9, 11, 12, and so forth.
Yeah.
But since I'm only looking for median, I can tell what the highest 4 are. Can you?
14.
Drake, Evan, Wanda, and Zelda.
Kurt. Okay.
Okay. Drake is the shortest
of
those. So my median, Drake is the shortest on the big end. And what is the biggest on the short end? My 4 shortest are Belle, Jasper, Sarah, and Yanni. And Yanni is the biggest one. So Yanni would go right there. So halfway between Yanni and Drake. So the only one I have to know are those 2. Now whether that's
11 and 10.
10.5, yeah. So whether that logic saved me time or not, I'm not sure.
Yeah.
It is interesting logic though. That
I've never thought
find
of
the
that.
median, we don't really need anything but the number 4 and 5 spots.
Yeah, I never thought of that before, actually.
Yeah, actually I didn't either until I just looked at this problem.
It's weird.
It all depends on whether they're asking for median or mean. Or mode. If they wanted mode, we'd probably have to find each one of them and list them all out. This is easier. This is not as easy as it looks.
Yeah, I was looking at it. It's not just...
What's the obvious first step?
Well, you just factor it.
Into what?
X plus 1, x minus 2. So then you get x equals negative 1 and x equals negative 2.
It's not an equation. If it was an equation, you'd get that. But because it's an inequality, we can't say for certain what it is. There's a technique that I always have to use, and then I realized that I really didn't have to use the technique as long as I'm multiplying two linear factors together. If you're doing something like this, then I wouldn't know how to do it without using this technique.
Okay.
The technique is a line chart. Use a line
chart.
Here's how I would do this. What are the critical points?
Negative 1 and 2.
So I put negative 1 there. I put 2 over here. I go to the left, to the right, and in the middle. If I try a number to the left of negative 1, do I get a plus or a minus on the left side of this inequality?
On the left side?
Yeah, in other words, when I do a line chart like this, whatever the sign is in this region, it's the same regardless of what number I pick. So if I want to figure out what that sign is, I'm going to try minus 2. Okay, when I plug in minus 2 for x, that's negative, that's negative. Negative times negative is positive. That means that it's plus in that region.
Okay.
In between, let's try 0.
0 plus 1, 1.
Don't even need the numbers. It all comes down only to the signs.
So it'd be negative.
Negative everywhere in that region. So all we have to do is try one number, and then everywhere in that region. And then if I try a number 3, we got positives.
Yep.
Now we know our answer. Our answer set is this area and this area. What is that? That is J.
J. Okay.
Now, could I have figured that out without doing the line chart? I'm not sure I could have, actually. And I know that when you have division going on, it's hard to do it. Maybe some people can do it, but I can't. I have to use this technique. And this is a pretty easy technique if you know it.
Yeah, it's pretty good, actually. I like it.
Yeah. It's worth knowing that once you have the critical points, then all numbers in that region are going to produce the same sign.
Yeah.
Let's see if this is a 2-minute problem.
Yeah, that's what I'm looking at. So you need to get the radius.
It is a 2-minute problem.
Yeah, it's not too bad, I think.
Where's the center of this circle?
Let me see. The center?
Mm-hmm.
Trying to think. A, B...
You definitely
X.
need to remember the general equation of a circle.
Yeah. I was thinking x minus a squared.
X minus h squared plus y minus k squared. And h and k are the center. So the center would be at 0, 2.
0, 2, yeah.
Right there. What's the radius of this circle?
So isn't it if the radius is 2?
Uh-huh. Because it's the radius.
So then you have to get the area next, I think.
Well, we know that this point is tangent to the x-axis, right? So they want the amount of the area that lies in a first quadrant. So that would be half the circle.
Yeah.
What's the area of the circle?
Well, then it would be, that's not it, right? I was thinking 4 or 5, but that's not right, because that's just the normal.
No, it is.
Oh.
Area of the circle is pi r squared. Well, r is 2.
Oh, 2. So 4, yeah.
4 pi is the area of the whole circle. 2 pi is the area of
2 pi.
the half that lays in quadrant 1.
Okay.
All right. 51, area of 51. That would be a good place to stop. We can remember it. Easy.
Yeah, I'll circle it.
My kids and I went there. We went to Roslyn when they were teenagers, and we went and tried to find area 51. Roswell, New Mexico. So
yeah. Oh.
it's a fun little trip, actually.
Okay.
All right, Anthony, I will talk to you next Thursday.
Yeah, cool. I'll see you then.
All right, bye-bye.